Here we are solving Pure Math 2 January 2024 paper. In the previous video we solved from question number 1 to 6. Here we will start from question number 7. This question number 7 is from chapter 5 Sequences and Series. It says wheat is grown on a farm. In year 1 the farm produced 300 tons of wheat. Year 12 the farm predicted to produce 4,000 tons of wheat. Model A assumes the amount of wheat produced on the farm will increase by same amount each year. This is a very important one. When the question says same amount every time, it's arithmetic series. When the same question says same percentage every year, that's geometric series. That's the difference. So here it's arithmetic series, and they want you to find the amount of wheat produced in year 4. So basically you are given A, the first term, and then the 12th term, 4,000. They want you to find the 4th term. So for the 12th term, the formula is nth term formula, A plus n minus 1d. 12 minus 1d is given as 4,000. So 4,000 minus 3,000 is 3,700. D is 3,700 divided by 11. Now the formula to find the 4th term is A plus 3D. Find the answer, round it to nearest 10. So A plus 3 times 3,700 over 11. 1309, round it to nearest 10, it's 1310 tons. That's all. That's for part A. Let's move on to part B now. Model B assumes that the amount of wheat produced on the farm will increase by same percentage every year. So this is geometric series. They want you to find A2. So the formula for A2 is equal to, first before finding A2 we need common ratio. We have given 300 and then the 12th term is 4,000. Now how do you write the 12th term? A times r power 11 is 4,000, right? That's the formula for nth term in geometric series. A is 300. Bring the 300 to the other side. So r power 11 is 40 over 3. R is 11th root of 40 over 3. So r is basically 11th root of 40 over 3. Okay, that's a decimal number. Probably I'll save it as A. Now we need to find the second term. The formula for second term is A times R, which is 300 times 11th root of 40 over 3. So here 300 times, I saved it as A. We got 379. They want the answer to be rounded to nearest 10. So it's 380 tons. That's all. Another 3 more questions. Let's move on to part C now. Calculate according to the two models the difference between the total amounts of wheat predicted to produce on the farm from year 1 to year 12 inclusive. They want you to find the sum of 12 terms for both models. For the first model, since it's arithmetic series, the formula is n over 2 2a plus n minus 1. N minus 1 is 11 times d. What is d here? 3,700 by 11. That's for arithmetic series. Let's calculate this first. 11 can be cancelled. So 12 over 2 is 6 times 2 times 300 is 600 plus 3,700. 25,800 tons using model A. For model B now, since it's a geometric sequence, we need to use the formula for geometric sequence, the common ratio, the value of common ratio, we calculated it. It's more than 1, so you need to use this formula. 8 times r power 1. R is basically 1.26 etc. power n minus 1 divided by r minus 1. We need to calculate this now. 300 times r is saved as a power n minus 1 close bracket divided by r minus 1. So when you round it to, okay, take it as 17935, 17935 dot something something, or you can put dot 2 something something. We don't need these values, we need the difference. So I'm going to subtract 25,800. 7864, round it to nearest 10, 7870 tons. That's the answer for this. Question number 8. Use a counter example to show that the following statement is false. This is a statement: n square plus 3n plus 1 is prime. We need to prove that this statement is wrong for any one of the real number. So you can do just mental math. If you put replace n by 1, it's going to be 1 square is 1, 3 times 1 plus 1 is a prime. When you put 2, it's 4 plus 6 plus 1 is also a prime. When you put 3, it's 3 square plus 3 times 3 plus 1, 19, a prime number. When you put 4 there, 16 plus 12, 28, 29 is a prime number. For 5, it's going to be 25 plus 15 plus 1, 41 is also a prime. When you put 6, it's 36 plus 18 plus which is 30, 40, 54 plus 155 is not a prime. There you go. So you just need to conclude that is not a prime, therefore the statement is false. That's all. You don't need to show all this thing. If you can straight away find the number 6, you just need to show only this line. That's all. Let's move on to the next part. Use proof by exhaustion to prove that n square minus 2 is not a multiple of 4 for all real numbers. You see, usually for proof by exhaustion, we need to have finite number of cases. So you can prove that for each and every case. But when they say real number, natural numbers, there are infinite natural numbers, right? So you need to divide them into certain categories to prove this statement. What we can do, we can divide them into even and odd, 2k and 2k plus 1. All natural numbers can be divided into two categories, even and odd. So let's sub in 2k in here, n square minus 2. You'll get 4k square minus 2, which is not a multiple of 4. Not a multiple of 4, because 4k square is a multiple of 4, minus 2 is not a multiple of 4. And then if you replace n by 2k plus 1, n square minus 2 is 2k plus 1 whole square minus 2, which is 4k square plus 4k plus 1 minus 2 is minus 1. So when you expand it, you'll get 4k square plus 2ab is 4k plus 1. Plus 1 minus 2 is minus 1. This is also 4 times k square plus k, which is a multiple of 4. Minus 1 is not a multiple of 4. Not a multiple of 4. So you need to write the conclusion now. We proved that it's not a multiple of 4 for both cases. Now we need to write the conclusion that for all n belongs to natural number, n square minus 2 is not a multiple of 4. That's how you conclude. Question number 9 from trigonometry, solving trigonometric equation. Okay, first write it as sin x times replace tan by sin over cos is equal to 5. So sine times sine, sine square is equal to, bring the cos x this side. Replace sine x by 1 minus cos square x. So we have an equation in a single trigonometric function. Put everything this side, you will have cos square x plus 5 cos x minus 1 is 0, which is a quadratic equation. Solve this quadratic equation. Go to equation number 3, 1, 5, negative 1. Negative 5 plus or minus square root of 29 over 2. So cos x is negative 5 plus square root of 29 over 2. Negative 5 minus square root of 29 over 2. But the value is smaller than 1. The next value is bigger than 1. That means this has no solution, because the range of cos x is minus 1 to 1. So we will use only this value to find the solutions within this range. So that's what we are going to do next. So we have cos x is equal to minus 5 plus square root of 29 over 2. X is cos inverse of this. Okay, we need to use the degree mode. Cos inverse of minus 5 plus square root of 29 over 2. 78 point something. I'm gonna immediately store it as a 78.89 etc. I stored it as a, that's not the solution, that's a principal value. We need to solve it between 0 to 360. 0 to 360 degree. We are going to use the CAST diagram, ASTC diagram. The limit is 0 to 360. Cos will be positive in here and here. This is theta and 360 minus theta. So the solution is theta. They want the solution to 1 decimal place. So it's a 78.9 degree, comma 360 minus the answer. 281.1 degree. 281.1 degree. That's all. 2 solutions for this equation. That's it. Let's move on to the next part now. We have a graph given. Okay. Now it says, okay, this is the function representing the graph. A sine 2 theta minus 3 pi over 2 plus 2. All these transformations will not affect the y coordinate. Okay, let's read the question first. It says PQR lie on a curve. Okay, the y coordinate of P is 7. The y coordinate of P is 7. They want you to find the value of A. Okay, you need to understand, if you look at the sine graph, it's negative 1 and 1. Okay. If it becomes 7 by adding 2, before it was 5 actually. The y coordinate was 5. After moving 2 units up, it becomes 7. So it was 5. So A is 5 actually. Because if A is 5, the function becomes 5, the maximum minimum value becomes 5 or negative 5. So A is 5. Straight away you will know A is equal to 5. So the answer for part A is equal to 5. Now find the exact coordinates of Q. They want you to find the exact coordinates of Q, this point. If you look at the sine graph, this was Q initially. After moving the graph to the right side certain units, because of the translation, we got the new point Q here. Okay, so what we need to do here, we need to take this point, which is pi over 2, 2 pi over 2, 3 pi over 2. The x coordinate of this point initially was 3 pi over 2, and then apply this transformation. So you need to take it as 2 theta minus 3 pi by 8 is equal to 3 pi over 2. and then find the theta. So 2 theta is 3 pi over 2 plus 3 pi over 8, which is basically 3 over 2 plus 3 over 8. 15 over 8 divided by 2 is 15 pi over 16. That's the theta, x coordinate of Q. That's the x coordinate of Q. And then the y coordinate, think about it. Here it was 1 and minus 1. When you multiply by 5, it becomes 5 and minus 5 instead of 1 and minus 1. And then when you move upwards 2 units, this 5 becomes 7, this minus 5 becomes minus 3. So the coordinates of Q are 15 pi over 16 comma negative 3. That's all. That's a 3-mark question. Let's move on to the next part. Find the value of theta at R, giving your answer to 3 significant figure. Part C says we need to find the coordinates of the point R. If you look at the figure, they're talking about this point. That's basically the 4th point actually. So we take the original equation, y is equal to 5 sine 2 theta minus 3 pi over 8 plus 2. The coordinate, y coordinate of R is 0. We don't know the x coordinate. So replace y by 0 here. So 0 is 5 sine 2 theta minus 3 pi over 8 plus 2. Bring the 2 here, this side minus 2, divide by 5. You'll get sine 2 theta minus 3 pi over 8 is equal to minus 2 over 5. Basically, you need to solve this. You need to treat this as a trigonometric equation, harder trigonometric equation. Solve it and take the 4th solution. Why 4th solution? Look at the figure. This is 1, 2, 3, 4th solution. We need the 4th solution. So you need to solve it. How do you solve it? Up to you. Whatever method you learned in solving harder trigonometric equation, apply the method. So the method I teach, you need to find sine inverse of positive 2 theta minus 3 pi over 8 is sine inverse of positive 2 over 5. You don't take the negative value, you take the positive value. You need to use radian mode, sine inverse of 2 over 5. Okay, I'm going to store this value as A. That's the principal value. 4115, 0.4115, etc. That's the principal value. Now we need to solve it, find the 4th solution. Okay, you need to use the CAS diagram. Now listen to me carefully. In the method I'm teaching, you can go through my video and learn the method if you want. Since you have minus 3 pi over 8, we are starting it from 0. This is 0 pi and then back to 2 pi here. Sign will be negative in here and here. So the first solution is, since you have minus 3 pi over 8, you need to take a solution before 0. So before 0 is basically minus theta. That's the first solution. Second solution is, when you go one round, it's pi plus theta. Second solution. Third solution is here 2 pi minus theta. Fourth solution is going to be 3 pi plus theta. That's what we need. Theta is the principal value. So we just need to add 3 pi to it. Is equal to 9.836 something. That's 2 theta minus 3 pi over 8 is 9.8 something. Add 3 pi over 8, divide by 2. Add 3 pi over 8, divide by 2. Write the answer to 3 significant figure, 5.51 radians. 5.51 radians. That's the x coordinate of the point R. That's all. Question number 10. We have a figure given and the question says, Figure 2 shows a sketch of the curve with the equation y is equal to blah blah blah. The function is given. The point P is the only stationary point. You can see point P here. That's a stationary point. Okay. Use calculus to show that x coordinate of the stationary point P is 9. So whenever the question talks about stationary point or turning point or maximum or minimum point, you have to differentiate the function and equate it to 0. dy by dx is equal to 0 to find the x coordinate. So first you can write the function as y is equal to half x square plus 1458 cube root of square root of x cube is same as x power 3 over 2. Put it in the numerator, x power minus 3 over 2 minus 74. Differentiate it. You will get half times x square becomes 2x plus 1458 times minus 3 over 2 x power minus 3 over 2 minus 1. And then the 74 becomes 0 is equal to 0. Make x as a subject. So here you will get x and then minus 1458 times 3 over 2 is 2187. 2187 x power minus 5 over 2 is 0. So x is equal to, bring this term this side, it's going to be 2187. I'm going to put it as divided by x power positive 5 over 2 and bring it here to make x as a subject. X power 5 over 2 plus 1 when you multiply. X power 7 over 2 is 2187. So x will be 2187 to the power 2 over 7. So basically the answer power 2 over 7 is 9. 9 is the x coordinate. So x is equal to 9. That's all. It's a 4-mark question. You just need to know how to differentiate and make x as a subject. Let's move on to part B of the question. Part B is a 5-mark question, okay? The line L passes through, I'm going to put the figure here maybe. Okay, here is the figure. The line L passes through point P. Okay? We don't know the equation of the line. All we know is the x coordinate of P is 9. Now the region R is shown shaded bounded by the curve. The equation x is equal to 4. This line with the equation x is equal to 4. Use algebra to find the exact area. Okay, the x coordinate of this point is 4 actually. So basically if you integrate the curve from 4 to 9, you will get this whole area. You will get this whole area minus this little rectangle. You will get the region, shaded region R. That's what we are going to do. So first let's integrate the function from 4 to 9. So integral 4 to 9, the function is half x square or x square by 2 plus 1458 x power plus 1458 x power minus 3 over 2 minus 74 dx. What I'm trying to do, I'm trying to find the whole area below the curve, this whole area. You need to integrate it carefully. It becomes x cubed by 3 times 2, 6 plus 1458 x power minus 3 by 2 plus 1, which is minus half by minus half minus 74x, sub in the limits. So I'm going to carefully sub in the limits now. The upper limit 9 cube over 6. 9 cube divided by 6. It's 243 over 2. And then 9 power minus half is 1 over 3. This whole thing I'm going to write it separately. Minus 2 times 1458 because of divided by minus half times 1 over x power positive half. So I'm going to calculate this. So it's basically 2 times 1458 times 1 over 3. 972 minus 972 minus 74 times 9, 666, that's upper limit, minus lower limit. Now replace x by 4, so it's going to be 4 cube divided by 6, 32 over 3, minus the second term is going to be 2 times 1458 times 1 over x power positive half. Replace x by 4, 4 power half is 2, so we'll get 1458 minus 74 times 4, it's 296. We need to carefully simplify this. Now we have to carefully simplify this and find the area, and then go back to the figure. Let's say we get the area, and then we need to find the area of this little rectangle. The length is 9 minus 4, 5. We need the height, so we need the y coordinate of the point P. We have the x coordinate 9, sub in into the function to find the y coordinate. So this is the function here. If you replace x by 9 into the function, y is equal to 9 square over 2 plus 1458 divided by 9 power 3 over 2 minus 74. 9 square 81 over 2 minus, sorry, it's plus 1458 divided by 9 power 3 by 2. 9 is 3 square, 2 cancel, 3 cube is 27 minus 74. We got 41 over 2. So back to this figure, the y coordinate of point P is 41 over 2, or this point is 41 over 2. So the length is, the width is 41 over 2. So the area of the rectangle is basically 5 times 41 over 2. 205 divided by 2. So whatever we are getting here, we need to subtract 205 divided by 2 from this area. That would be the final answer. So I'm going to calculate this carefully. 243 over 2 minus 972 minus 666 minus 32 over 3 plus 1458 plus 1458 plus 296. This is what we got, minus 205 divided by 2. 373 over 3. 373 over 3 after subtracting this. That's the area. That's all. That's how we find this area. Area, the shaded region R.